Hello friends, so let's try to solve one more problem from IIT JAM 24, and this is from the mechanics, and this problem is very nice one, and this is all about to understanding the coefficient of restitution and all about the collision actually. So what is this problem? And this is one of the very famous problems. So most of the people remember the final result also, but we can just solve it completely. So what is this? A ball is dropped from height h to the ground, and if the coefficient of restitution is E, then the time required to ball to stop bouncing is proportional to which one? So obviously, so we can also first we can just analyze this thing. Suppose this coefficient of restitution is 1. Suppose this coefficient of restitution is 1, then obviously the ball will never stop and it will take an infinite time to be stopped. So that means it will be never stopped. So what we can do, we can just put E is equal to 1 and then what will be the time we can see. So here the time is also infinite and here the time is also infinite if you will put E is equal to 1. That is for the elastic collision. So if for the elastic collision, suppose the surface is not have some friction, not any friction, then obviously the ball will just get the same height and again come back to here. But here the coefficient of restitution is there, then what will happen? Ball will come there and next time it will go to the little height and next time it will again go to the little height, because each and every time it will lose some energy. We will discuss in the mathematical form what is going to happen, but we are sure that answer will be either A or either B, because for the C and D it is not suited for E is equal to 1. So students, in IIT JAM examination you can easily exclude two options by just comparing for the ideal situation. So this is very interesting and we will discuss this thing when we will go for the crash course and all this thing. Now let us try to solve it completely. So it's a wonderful problem and we can solve it in a very nice way. So what is this particular problem? So suppose this is my surface of earth. So initially the ball will fall from this height h, and then again what will happen? Due to this surface have some coefficient of restitution, so collision is not actually elastic. So next time it will go to some height h1. Next time it will go to some height h2, and finally it will just decay its height and it will finally just stop. So, and we have to find the time in form of h actually and the coefficient of restitution E. So we have to just use all this thing. So now, so if ball is going to, suppose this is my ball, and if it is going to fall from height h, then obviously the incoming velocity is v is equal to root under 2gh. So from before collision to this particular point, the velocity is 2gh. And what will happen? When it is going back into this direction, it will change its velocity, and that velocity v is equal to E into root under 2gh. So this will be v1 velocity, as it is just going to, it is going up into this direction. So now what will happen to this one? It will go up to there and again it will come back and again it will go there. So what will happen? The ball will fall down and again it will go up and again it will go down and again it will go up and something like this. So this is your V1. That means the first time it is going to move into this particular direction. So we have to write each and everything in form of time. So suppose this time is t. So this time is equal to, so v is equal to u plus, or you can put u plus gt, and initially it will be 0. So t is equal to v by g, and that value is equal to 2gh by g, and this value is equal to 2h by g. So this is my time t. In the second time, what is going to happen? It will just go with a different velocity. So initial velocity will be e time, so final velocity will be 0 at the height h, and initial velocity will be e time root under 2gh, and so that into, and that will be the negative sign. So this value will be 2gh minus gt1. So what will be this value? So this t1 is equal to E time root under 2gh by g, and that value is equal to E time root under 2h upon g. So similarly, we can find the second time, third time. So what will be T2? We can easily calculate T2 will follow E square root under 2h upon g. And what will happen? It will just go to the one particular series. So how we will write the time? So here we have to keep this thing in our mind. So this time is just T1, just T, and after then every time will be 2 times. It will go up and it will go down. It will go up and it will go down. So what will be the total time T? The total time T is T plus 2 times T1 plus 2 times T2 plus 2 times T3 and so on. And what will be this value? This T is equal to nothing, 2h upon g, plus I can take 2 common, and we have E time 2h upon g, plus we have E square time 2h upon g, and so on. So what we will get? I am just going to solve here. We can take this value is 2h upon g outside, and what we have 1 plus 2, and here is the series, that is E plus E square plus E cube and so on. So we can have this particular series E cube plus E to the power 4 and so on. So we can easily solve this one. So 2h by g root under, and 1 is there, we can take 2e common, 1 plus E square plus E cube. So this will, and E is obviously between 0 to 1. This is all about, we know, for the coefficient of restitution. So we can just go for infinite series of GP, and what we will get? We will get 2h upon g, that is 1 plus 2e, 1 by 1 minus e, and this value is equal to 1 minus e plus 2e upon 1 minus e into 2h upon g, and this value is equal to root under 2h upon g. So this is my time, 2h upon g, and root under, sorry, this is not root under, so we can easily solve. This value is equal to 1 plus e by 1 minus e. So answer number B, you can see that will be the correct one. So this is a wonderful question, but in general this type of question people remember the final result also, because this is very common question that once your particle is going down under the gravity, then how much time it will take. So similarly you can also calculate what will be the total distance it is going to cover. So students, try to do this one. Maybe this question can come into the next exam. So just you can follow this rule, the basic concept. It will be all you needed into the IIT JAM examination. Thank you.